Page 380, continuing lesson 6.3 on solving systems using elimination. What we're going to look at today, starting with problem 3, is we're going to have a little bit of some situations that we haven't dealt with yet. So look at problem 3. The question is, what is the solution of the system of equations use elimination? On your test, by the way, I'm not going to tell you what way to solve it. You just have to decide what's the best way. Okay, kind of like what's the best tool when you're fixing something. You get to decide what's the best way to solve the equation. What's happening on this problem, a little different than what we looked at yesterday. Yesterday, we had either coefficients that were the opposites of each other, where we just added and they canceled out, or if they were the same, we multiplied one of them by -1. What we're doing today is not too much worse than that. It's just a little different. So if you look at this problem, we don't have either of those cases. What we're going to do, it's kind of like getting a common denominator. We're going to look at our coefficients of x and our coefficients of y, and we're going to imagine if these were fractions, what our common denominator would be. So if you look at the 2 and the 7, if we had 2 and 7 as denominators, then 14 would be our common denominator. If we have 15 and 5, if we look at the y's, then 15 would be our common denominator. If you'll notice with the x's, if we said we were going to go to 14, if we go to 14, we're going to have to change both of these, which means we're going to have to multiply both equations. We can do that, but it's less work if we only have to multiply one equation. So notice with the y's, this one, the first equation already has a 15. So all I have to do is multiply the second equation by something in order to get that to match up. Now remember though, we don't want them to exactly match up. We want them to be opposite so that they'll cancel. The second equation does have a negative or subtraction sign in front of it, so we're already in good shape. So you can see what the book's doing here is they are saying, let's multiply the second equation by 3. Now they didn't really show multiplying it by 3, but that's what they were doing right here. So they're multiplying by 3, and that gets them to this 21x minus 15y equals 51. At that point, we're at the same spot we were yesterday. You can just cross those out if you want, and then divide by 19. You get x equals 1, and then you can substitute that back into either equation. So here they substituted it into the second equation. They worked it out. They didn't show all their steps just to make your book lighter to carry, I guess, but they got -2, and then they said the solution is 1, -2. So those lines intersect at the point 1, -2. So if we look at the guide at 3, again, it says, how can you use the multiplication property of equality to change the equation? Basically, on your test, you're going to get these equations, and it's going to say solve this system of equations is what it's going to basically amount to. So what I would suggest doing first of all is writing the equations down next to each other, and then we can try and think about which variable we want to eliminate. Again, it's going to be easier if you can find a way of doing that by just multiplying one of the equations by something, but sometimes we'll find out as we go through this, sometimes we'll have to multiply both equations by something. So if you look at the x's, we've got 3 and 5. Ignore the negative signs. 3 and 5, we would have to have a common denominator. If you think of in those terms of 15, I would have to get 15 and -15. That would involve changing both of these, so I'd have to multiply both equations by something. With the y's, we've got 6 and -2. So with 6 and 2, common denominator would be 6. That would involve only multiplying one equation by something. So that would be the easier route for us on this problem. I've got these in the opposite order of what the book had, so let me flip-flop these real quick. So we can take the first equation. If we multiply by 3, then our y's will be opposites and they'll cancel. So this would be negative 15x minus 6y equals 18. And I'm writing it below the other equation because I know these y's are getting ready to cancel out. So we add these together, it'd be negative 12x equals 24. So at this point, we just divide by negative 12 on both sides of the equation. And we've got x equals negative 2. So at this point, we need to substitute this x equals negative 2. We need to substitute negative 2 in for x in one of the equations. If you'll notice the second equation, there's no negatives in that one. So that could be a simpler way that you don't have to keep track of the negatives as much. Either equation you substitute it in, you'll get the same thing though. So let's say we multiplied by 3, and then we did this, and now we're substituting. I'll just do a dotted line here, just showing that equation, where that came from. So then we can add 6 on both sides. So 6y equals 12. And then if we divide by 6, y equals 2. And then at that point we can say that negative 2, 2 would be our solution, which means these lines intersect at the point negative 2, 2. So problem 4 steps things up just a little bit. It's kind of our next level on the video game, so to speak here. We've got a solution of this system of equations. The deal is, again, if you think of common denominators here with the x's, we've got 3 and 4. So that would have a common denominator of 12. Again, we'd have to multiply both equations, obviously, because neither one has a 12 right now. And then if we look at our y's, we've got 2 and 3. So with those, common denominator would be 6. It's kind of a decision at that point. We're going to have to multiply both equations either way. Here's my thought process. I've got 12 and I've got 6. 6 is smaller. I'm going to do that one. Okay, that's just how straightforward I'm going to think about it. Again, either way you do this, you should get the right answer if you do it correctly. We're going to modify a little bit what the book did here, though. I'm not a big fan of exactly what they did. So they said, let's multiply the first equation by 3. They multiplied this by 3. And then they got 9x plus 6y equals 3. That part I'm okay with. The second thing is, remember, we're trying to eliminate the y. So if we multiplied this and then we've got a 6y, let's think about what we want the other one to be. If we have a 6y, what does our other coefficient need to be so those are going to cancel? And the deal is we need it to be the opposite, right? We've got 6, we need a negative 6y in order for those to cancel. So to get the y to be a negative 6, we need to multiply by a negative 2. So the book here just multiplies by 2, and then they said, oh, we'll just subtract it, which means changing all the signs in your head and all that stuff. To me, that doesn't make sense. I'm just going to multiply it by negative 2. This would be me writing the book. I would say multiply by negative 2, and then we're going to have negative 8x minus 6y equals 4. So at that point, we can add these together. The y's cancel. With this, that would be 1x, or just x if you want. 3 plus 4 is 7. If you want to divide by 1, you can. It's not going to change anything, though. So x equals 7. And then if you substitute that into either equation and work that out, you get negative 10. And so then 7, negative 10 would be the solution for that system of equations. So if we look at the got it 4, we are basically going to be solving this system of equations. So I'm just going to start by rewriting these. Or in my case, just copying them. And again, our first step here is deciding which variable we want to get rid of and which one we want to keep, which one we want to try and get to cancel out. So you can look at your x's, look at your y's, think about common denominators, and think about, is there one that allows you to get your answer with only multiplying one equation, or do you have to multiply both equations? If you have to multiply both equations, going with whatever the smaller common denominator, so to speak, is might be a little bit simpler with smaller numbers for you to work with. So looking at the x's with 3 and 4, we would have to go to 12. With the y's with 3 and 2, we'd have to go to 6. So I'm going to go with the one that goes to 6 instead of 12. So to get this to a 6, I'm going to multiply by 2. Now remember, the other one has to be the opposite in order to cancel. So that was 6y. The other one needs to be a negative 6y. There's already a subtraction or negative sign here, so that sets up nicely. So if you want to multiply that by 3, it'd be 9x minus 6y equals negative 30. At that point, we can go ahead and combine those together. The y's are going to cancel. Doesn't look real great. 17x equals negative 68. We divide by 17. Actually comes out as negative 4. So for not looking very nice there, that actually worked out pretty well. So negative 4 is our x value. So this is kind of the first things we're doing, I guess, after we multiplied. And then we can substitute that into either equation. I'm just going to go with the first one just because there's no negatives on the left side. Again, either way is fine. You should get the same answer. So if we work this out, multiply those, add 16 on both sides. Divide by 3. And that leaves us to negative 4, negative 1 for our solution. Again, if you have time, I would substitute it into the second equation and make sure if you put a negative 4 and negative 1 in for x and y that works with that equation as well. Problem 5, the question is how many solutions does the system have? So that's a different question that we haven't been asked. So what they're doing here, just like we've done before, they're going to go to solve the equation. Most of the problems, you're going to get one solution. That's what we've been doing. There's one point where they intersect. That's one solution. This one, you can see they actually did decide to multiply by negative 2 and get the things to cancel instead of worrying about subtracting later. What happens here is actually the x's and the y's cancel. And then on the other side, we've got 18 minus 18. Those cancel also. Everything canceled. This is kind of odd. So they ended up with 0 equals 0. What we're deciding at that point is if we had a true statement or false statement like we did earlier in the chapter. This is a true statement. So since it's a true statement, we have infinitely many solutions, which basically, again, means that these lines are identical to each other. These lines are both maybe something like this. It doesn't look like they're the same, but if you think about it, if you take the second equation, the bottom equation, if you just double everything, if you multiply by 2 on both sides, you get the same exact equation. So If you ever would recognize they are the same equations, you could just automatically say infinitely many solutions. Not too much work just to work that one out otherwise though. So let's look at the got at 5. Same question, how many solutions does this have? So this one, everything's identical on that left side, so it's not going to cancel right now. But if we multiply one of them by a -1, then we'll get some opposites that'll cancel. So that'll be 2x minus 5y equals -7. The other one will just keep it as it is. So then on the left side, everything cancels, so we've got nothing. So we'll go ahead and put a 0 there. -7 plus 12 is 5. So we get to a point here of it saying 0 equals 5. So since 0 is not equal to 5, this means there is no solution, which means the lines don't intersect, which means the lines are parallel. No solution is sufficient answer, though, for this problem. So there's a flow chart here that kind of helps you decide which thing to do. You can kind of just look through that on your own if you want. Again, it's just kind of thinking about looking for the easiest way that we can to solve these equations. We're going to look at a different problem here. It's not in your book. 3x plus 2y equals 6. 2x plus 5y equals 10. We're going to solve this system of equations. So if we look at these with the x's, once again, we've got 3 and 2, which we could use 6 for those. 2 and 5 would be 10. 6 is less than 10. I'm just going to work off of that. So first one I'll multiply by 2. So that'd be 6x plus 4y equals 12. Now remember, the second one needs to be the opposite. So if that was 6, our other one needs to be a -6. So we could multiply by -3. So it'd be -6x minus 15y equals -30. If we combine those together, then the x's cancel. We got -11y equals -18. So we divide by -11, and we've got negative divided by negative is positive, so that'd be 18/11. I'm just going to leave it as 18/11. We definitely don't want to get a decimal out of this. Changing it to a mixed number is not really going to benefit. If it was a word problem, we might change it to a mixed number, but since it's not, I'm just going to even leave it as 18/11. And then I'm just going to go ahead and substitute that into this other equation. And it's going to be a little bit of a job here with the fraction, but nothing we can't handle. So we'd have to get a common denominator with that. And then divide by 2. Dividing by 2, normally we might do keep change reciprocal. On this one, since the numerator is even, we could just think about if we have 20/11, if we take half of that, half of 20/11 would be 10/11. So 10/11, 18/11, or 10/11, and 1 and 7/11 could be a solution for that problem. So they don't always have to come out evenly, I guess is kind of the idea behind that problem. A lot of them they're going to give you will come out evenly at this point since you're just getting the hang of it, but it is possible that things don't come out evenly as well. So this gives you an idea of how to solve system of equations using elimination. Have a good day.